I'd like to demonstrate my Algebra Tile program. It's written in JavaScript, and I also use jQuery and jQuery UI. I'm not a developer, so this program is a work in progress. You'll probably see some things that should be changed or improved, and I'll talk a little bit about that after I show you the current capabilities of this little program. So first of all, as you can see, positive values are represented by green, negative values by red. And currently the numbers and the variables are represented by bars whose lengths are equal to their values and the widths are 1. Of course, that's not how these have to be represented, and you'll see that change a little bit later. The variables are represented by random length bars, which you can then adjust since they're variable by using the slider. You can change x and make it even negative, and same with y. So first of all, let me show you the capability for simply adding. So let's take 3 and 5. You just drag them together, and they'll give you an indicated addition rather than simplifying the addition, and I'll show you in a moment about how you can simplify the addition. But we'll add x to x. You get x plus x. We'll add that to there, and we're sort of forming a little linear polynomial. Add another x, and if you want to simplify all of that, you double click on it, which is sort of like opening a little editing window, and then in this window you can drag like terms together, like terms being tiles that are the same size and shape. So the x and the x add together give you 2x, and then you can add that for 3x. I'll put this over here, and then click on the check mark when I'm done, and I've got my 3x plus 8. So let me show you multiplying. Let's take 4 and 2. That's boring. Let me reload this. Let's multiply 4 and 5. So multiplication works the way you see it normally. The standard way with Algebra Tiles is you try to build a rectangle by using one of the factors as like a horizontal bar and the other as a vertical. So we have to make one of these bars vertical, and that's done by right-clicking and selecting transpose. And now if I put the 4 up to the 5, it's going to build a rectangle that's 5 by 4, which is 20 little tiles. So that's simply how you do multiplication. Now the nice thing is you can factor that too. Right-click and select factor, and it reverses the process. The important thing for factoring is you've got to have a rectangle to factor. You can also transpose this, just like before. And so now I'd like to show you multiplying a variable by a variable. Same thing really, just we'll multiply x by x, transpose one of them, put them together to get a tile that's x by x. And I could multiply x by y also. Let me transpose that, and there we go with x by y, and it's fun to play with the sliders. Then you can see what happens. You can make x negative. X squared is still positive, of course. Xy is negative until I make y negative. Okay, so now also you can multiply a variable by a number. Let's multiply 3 by x. I'm going to make x positive. And so I'll again transpose one of them, doesn't matter which one, and then put them together, and I get a rectangle whose width is 3 and height is x. So that's 3x. So now I would like to, let's add x squared and xy. So I built a little polynomial there, and it doesn't look so good because, well, its edges don't quite agree. Sometimes it's impossible to make them agree, but here I can make them agree. I can simply double-click to open this editing window, and I can do various things with the terms within this polynomial. If I right-click on a term, I can transpose a one term, and now they meet and they look good. But not only do they look good, I can factor now because it's a perfect rectangle into x plus y and x. I'm going to reload this page so that I can start from scratch, and let's multiply x plus 2 and x minus 3. So I'll create x plus 2 and x minus 3. Transpose one of them so that I can do the usual multiplication. And there's the product. And of course, this can be simplified to a trinomial. The 2x and the negative 3x combine, but they don't actually combine yet because they're not the same shape. All I have to do, though, is right-click on one of these, transpose it so that it is the same shape, and now the 2x and the negative 3x will combine. And I can say I'm done, click on my check mark, but again, I get this ugly looking arrangement, so if I don't like that, I can rearrange it however I want. And in fact, if I right-click on an individual term, there's these things I can do. I can flatten that again if I want it like this. What I'd really like to do, though, is factor this x squared minus x minus 6. So to factor, I always need a rectangle. And now the question is, can I reverse the process that I used before to unmultiply, to factor this? And so I need to form a rectangle. That's the key. Well, these two tiles, the negative x and the x squared, fit together nicely, but this negative 6 seems to be a problem. What am I going to do with it? Well, if I put it here, well, I have all this space here. And I can't really do anything about that. Let's rearrange this negative 6 to 2 rows of tiles. So 2 by 3, that's what change rows will do. And will that help? Well, actually, I know it will help because I remember how it was before. But I can also see that if I had 3, right up here, if I had 3 x bars, and down here 2 x bars, that would fill in this thing perfectly, making a nice rectangle. And I can actually get that if the 3 are negative and the 2 are positive, because that would give me a negative 1x, which is what I've got. So what I need to do is split this negative 1x into a negative 3x and a positive 2x. And I can do that by right-clicking and selecting Split. So what did I want? I wanted positive 2 and negative 3. So I can split 2 off of it. And there we go. And if I transpose this, well, then I can transpose this. And now I've got a fairly nice rectangle, which I can then factor. There we go. Okay, so now what gets really interesting is trying to factor something like x squared minus 1, which I know is factorable. Reload. So x squared, I'll build that by multiplying x by x, and then putting a negative 1 there. So there's my x squared plus 1. How would I factor that? I need to make it into a rectangle. And so if I put this down here, I can now fill in this area with an x and this area with an x. But they have to be opposite signs, because how else would I get them out of nothing? I have nothing there. What I want to do is create a 0x, which will then become a negative 1x and a positive 1x. So that's what this 0 is here. The 0, and then you can type any monomial here, x squared or y or whatever, but we want a 0x. There's my 0x, and I want to split it up into a positive 1x and a negative 1x. So we can put the negative 1x there and the positive 1x here, and we have a nice rectangle, which is then factorable. What I want to do next is show you that I can work with higher degrees than just quadratics. What I can do is multiply x by x by x to get x cubed. But the question is, how do I multiply x squared by x using the rectangle idea? I need one of these to be horizontal and one vertical. Well, what I can do is I can flatten this x squared. Right-click on it and flatten. And it gives me a bar that's 1 unit wide and x squared units long. And now I can transpose this and multiply x by x squared to get x cubed. And I can keep going. I can flatten again and multiply it by x again to get x to the 4th. I could also multiply it. Let me do this. Multiply. Well, that's very long now, so I'm going to shorten x with the slider so x cubed fits. And now I can, of course, multiply it by y. And I can right-click and factor to bring it back to what it was. What I would like to do now is factor x cubed plus 1. And sometimes when you are dealing with 1, software is not sure whether you want to add or multiply, so it asks you. But here I want to add. And how are we going to factor that thing? I'm going to double click on it. I need to turn it into a rectangle somehow that's not 1 unit wide, because that won't really factor. So what I can do is make this x cubed bar change its shape, go backwards. I flattened it before. I can undo the flattening by selecting reshape tile and maybe making it x units wide. That gives me a tile that's x by x squared. Maybe that would help somehow. Let me move this up here. Well, I could put this 1 down there, and then I have to fill in this space and this space. Well, this space down here is x by 1 because this tile here is x wide and x squared high. So I need an x tile. Getting it from nothing means I need to use a 0, 0x, and then split the 0x into a 1x and a negative 1x. And of course, the 1x fits perfectly there, but I've got this. I can transpose it, but it won't quite fit there. I've got this space here. Well, this space is x squared units tall, so what I need is an x squared bar in there. So I'm going to create a 0x squared, 0 term, and to get x squared I have to type xx for x squared. There's my 0x squared, and I will split that up into a 1x squared and a negative 1x squared, so that's what we've got. And well, one of these will fit in this area if it were reshaped. This x squared is x by x, but I need to change it to a 1 by x squared, so I will reshape, and width will be 1, and now it fits in there perfectly. Now what about this? Well, what am I going to do with this? So what I can do is actually move them down at the bottom, and then they fit perfectly. So, well, that didn't. A little bug, or well, it didn't quite understand what I wanted. There we go. So now I'm going to right-click factor, and it's factored it. And if you don't like the fact that this factor is not in standard form, I will simply rearrange that. And now x squared minus x plus 1. And I'm running short on time. This turned out a lot longer than I thought, but let me just mention a couple things I'd like to do in the future. There's a bit of an inconsistency with indicated addition when you add the two polynomials together, but when you multiply them, it doesn't. It actually does the multiplication. It simplifies almost. So I'd like to change that. I'd like to implement subtraction and division in some way, and I'd also, probably most importantly, like to generate some games where students are actually guided into figuring things out on their own using this by playing some games. So I hope you enjoyed this demonstration.